some understanding
Sir,
about UV light.
we can't see it, and it comes from the sun, and it can
Mhm.
cause skin cancer.
Hmm. Okay, that's good. Achari, so this is the electromagnetic spectrum. So the entire summary of the chapter is in this particular diagram, right? So what is electromagnetic spectrum? So it is the the combination of all the waves which are present in the universe, right? We can have the waves from radio wave to microwaves to infrared to visible light to basically X-rays and gamma rays, right? So if I just try to summarize this, let me just insert a slide here. So first of all, you have the radio waves, right? Then you have microwaves. Then you have infrared waves. Then you have visible light. Then you have ultraviolet light, ultraviolet waves. Then you have X-rays, and then you have gamma rays, right? And what is the order of frequency? So this particular radio wave has the highest wavelength, highest wavelength. If you recall the general properties of waves, we learned a formula that was speed is equals to lambda f, where basically we learned that lambda was what? Lambda was wavelength, right? And f was frequency, and v was the speed of wave, right? So it has the highest wavelength, and gamma rays has the basically lowest wavelength, right? And this order is basically goes in this direction. This order basically goes in this direction. So if we go from left to right, starting from radio to basically micro to infra to visible to ultra to X-ray to gamma, this is the order of wavelength over here. If I talk about the order of frequency, radio wave has the lowest frequency, and the gamma ray has the highest frequency. You can see that there is an inverse relation between lambda, and basically lambda is wavelength, right? And the frequency is shown by small f, right? Can anyone highlight why is there inverse relation between wavelength and frequency? By just seeing at this formula, is there inverse relation between lambda and frequency? The wavelength and frequency. It is obvious over here. If you see the formula here that states speed is equals to lambda f, if you make basically wavelength subject, the formula becomes speed upon f, right? So what is the relation between wavelength and frequency? It's an inverse relation, right? You can see that there is an inverse relation between lambda and frequency. That is how you can just learn that if it is the highest wavelength, it would have the lowest frequency here. If it has the lowest wavelength, that particular wave would have the highest frequency here, right? So that is how the spectrum is basically created, and that's how you should learn these particular trends here, right? So if I want to take you to specific diagram with labeling of wavelength and with basic examples over here, you can see that over here, right? And visible light क्या है हमारे पास यहाँ पे? Visible light is the light which is basically visible to your naked eye, right? You can see that this is the visible light वाला part. It has all the seven colors, ठीक है? That basically creates, it has seven colors which creates your white light, right? So that is in this particular part here. Achari. So again, this is saying that wavelength increasing basically in this direction, right? Wavelength is basically decreasing in this direction over here, right? So you can see that this one has the maximum lambda, maximum wavelength, and this particular gamma ray has the minimum wavelength over here. If I talk about the frequency, it has the maximum frequency at this point, and it has the minimum frequency at this point. Again, you can see that there is an inverse relation between these two. lambda max and frequency, right? Okay, so starting from radio wave, you can see कि the radio wave, this is the lambda, ठीक है, which you can see. This is the wavelength which is written over here. These are the wavelength values. ठीक है, you don't need to learn them. You just need to have an idea कि what is the trend. So just learning the trend is basically important. कि which one is the starting wave. If you want to learn in this way, that is the most easier one. Okay, we have radio, we have micro, we have infra, then we have visible light. So visible light has 7 colors, right? Starting from red and ending with violet. ठीक है, and then in between we have orange, yellow, blue, indigo. ठीक है, and violet over here. ठीक है, so and then we have ultra, then we have x-ray, then we have gamma over here. ठीक है, if you know this, if you have learned this trend over here, it would not be difficult to basically have an estimate idea कि radio wave would have the greatest wavelength and the gamma would have the lowest wavelength. And since frequency and can see कि frequency and lambda is inversely linked together, so if it has the highest wavelength, it would have the lowest frequency here. If it has the lowest wavelength, it would have the highest frequency here, right? This is the diagram with the values here, right? ठीक है. So if you just learn these boundaries here for the visible spectrum, that would be more than enough. ठीक है. So if I just dictate over here, red has the wavelength of 700 nanometer. ठीक है. And since it is going to decrease on, if we go from left to right, violet has the basically lambda, which is 400 nanometer, right? You can see it went from 700 to 400 nanometer, and it decreases so on and so forth if we go to gamma, right? So just learn these values here. ठीक है, that would be more than enough. ठीक है, so you would know कि if you are talking about infra, so infra की wavelength would be less than 700 nano, right? And if you talk about ultra, so उसके हमारे पास wavelength would be basically not smaller, greater, right? It would be greater than, because it is increasing on the left hand side. It would be greater than 700. If I talk about ultraviolet, basically wavelength, it would be less than 400 nanometer, right? So if you just know these boundaries, it would be enough to remember the trend over here, right? Okay. So now, starting from radio, you can see you have heard radio wave, right? You might have been listening to radio, FM radio over your cars or your phones and when you're free, right? So radio is basically mostly used in communication over here. That you can see as a transmitter over here. And then we have radio TV. Again, that comes under transmission over here, television. And then we have microwaves. Microwaves are mostly commonly found in the microwaves oven, which you basically use it to heat the food. Okay. And then we have infrared, which you basically observe in electric heaters, or basically whenever you just see, whenever it is winter, you see that some lights, some huge bulbs which are glowing very bright at orange color, that are producing basically infrared waves over here. Right? Then sun is producing visible light, right? Okay, and ultraviolet is basically produced by mercury lamp over here. This is just a good representation which combines the values and the application in just one diagram. Then we have X-rays, and X-rays you might have heard they're used in medical purposes. They basically to obtain images of your bones. Since X-rays can pass through your muscles, which we will learn in a while, don't worry, क्या होती हैं. So they can basically obtain pictures of your body, and they can find cracks in your bones. Let's say if you have a fracture, let's say if you have done some injury, they can basically find out the injury point over there. Then gamma rays, you might have heard they are used to kill cancer cells. Okay. So again, there are some benefits and there are also some drawbacks of these waves, which you will learn now, right? So I'm just introducing to you the entire AM spectrum. So this is the way you will learn this. And this is the diagrammatic way with applications over here, right? So if just the brief introduction about the EM spectrum is clear, give me a thumbs up. We learn about these in detail in the upcoming slides over here. If it is clear till now, give me a thumbs up quickly. Okay, that's good. It's clear to Mashal, it's clear to Hamza, it's clear to me, right? So now we're gonna dive into each type of the wave in detail. We will learn कि होती क्या है, how basically are they used in practical life, and what are the benefits and what are the drawbacks of each type of wave over here, right? So let's start with the first type. First of all, the properties of electromagnetic wave, right? So we're gonna start with general properties. आपके एग्जाम में आता है कि list the properties of electromagnetic wave of 3 marks, 2 marks. So you should learn at least three of them, ठीक है, from these. So what are the properties of electromagnetic wave? Okay, so let me just introduce to you from an example. Example, let's say we have sun here, right? We have sun, and let's say after sun certain orbit, we have Mother Earth here, right? Let me choose blue highlighter. We have Mother Earth here, right? It should be smaller than sun, obviously. Let me fix that, right? So we have Mother Earth here. You believe and you have observed this with your naked eyes. Okay, light basically travels from sun to Earth here, right? And in space we have vacuum, right? So this is the specialty of light waves, right? Basically, all the electromagnetic waves are basically traveling through space, right? They can travel through vacuum, right? So in vacuum, we have basically no air, right? We have no air over here. So all the electromagnetic waves in vacuum travel at the speed of light, that is 3 exponent 8 meter per second, right? And from experiments, the scientists have also found out the speed of EM waves in Earth also. Okay, so let's say if I talk about inside Earth, so all the EM waves travel again at the speed of light, that is 3 exponent 8 meter per second, right? So this is one of the first property which you will learn and which you should start learning ASAP, that all types of electromagnetic waves travel through vacuum with the same high speed as light does, right? So light is basically again a part of EM wave. And what is the property of EM wave? That all EM waves that covers ultraviolet, microwave, X-rays, gamma rays, ultraviolet waves, okay, they all travel at the same speed. And what is the speed of light which we have discovered through experiments? That is 3 exponent 8 meter per second, right? And it is almost same in air, okay, by experiments. And what are the properties of waves that they can exhibit? They can undergo reflection, refraction, diffraction, and they are all called transverse wave, right? Which we have learned in the last slide, right? So they are all transverse waves, and again, since they are transverse wave, we can have properties which we have learned in the last chapter also. Light K, we have reflection, reflection, diffraction. So all of the properties are true for all of these waves which we have just listed down over here, right? Okay, so the next thing which is K, they obey the formula, the law which we have learned of waves. The speed is equals to F lambda, right? This is followed by all of the waves over here, right? So if you think about this, हमने बोला है कि अभी speed of light जो है, that is speed of light is 3 exponent 8 meter per second. ठीक है, this is the speed for all of the waves of EM that covers all of the type of waves. ठीक है, so in our case speed is fixed, right? So what are the two things which are varying in the EM spectrum? If we make F subject, so we'll have this following relation, lambda. So we have the following relation over here. So these are the two things only which are varying of the EM spectrum over here, right? And which we have seen over here, right? Over here कि हमारे पास highest wavelength रेडियो की होती है, but we have the least frequency over here. But if we go from left to right direction, the order of wavelength is basically decreasing over here, right? So only two things are varying over here, which you can see: the speed, the wavelength, and the frequency. But the speed is fixed over here for all of the waves over here. So it makes it easier for us to do calculations and basically determine which type of wave are we encountering for a particular experiment. ठीक है जी? And again, you can just imagine light. ठीक है? Light क्या करती है? So if you talk about light, so it travels basically, and sun is producing energy. And if you sit on a sun under sunlight for half an hour, you also basically start to feel some energy. So it is transferring energy from one point to another point, and that type of wave is called basically progressive wave, which we have learned in the first chapter. Okay, so they carry energy from one place to another, and they can be absorbed by matter to basically heat up. We have conduction, convection, radiation, which we basically learned in the last chapters. So the higher the frequency, the smaller the wavelength, which we have seen by this relation, right? It's an inverse relation over here. So the greater is the energy carried over here. So gamma rays are more energetic over here. So they are saying that there is a relation between energy and frequency, right? So the greater the frequency, the greater the energy. So don't worry about this. You don't have a formula for this, and you're not tested upon this relation over here. Just remember this roughly. Okay, the greater the frequency, the greater energy it would have. Okay. Just imagine gamma rays are used to kill cancer cells. Okay. So they can kill cancer cells only if they have high enough energy to destroy that particular cell, right? Okay. So every sort of wave has drawbacks and benefits, which you will see in a while, right? But gamma rays is the most basically dangerous one, which you will see why. So if you recall Marie Curie, if you recall Marie Curie, She was the only female scientist in the scientific society history, right? Marie Curie. So she was basically, we will learn this in chapter radioactivity. Who was she? So she was working on radioactivity, right? She discovered radioactivity, right? So she used to basically carry, she used to carry uranium. Okay, just imagine uranium. It is a highly radioactive element in her pocket, right? In her pocket, because she didn't knew about this phenomena. उस time पे ये phenomena discover नहीं हुआ था. So what happened? It basically emitted some gamma rays. ठीक है? It emitted gamma rays, which basically went inside the Marie Curie. Basically it caused cancer in her stomach side. It caused cancer in her body. ठीक है? And she died of cancer, right? So she died for the love of physics. Okay, so we have crazy scientists in the world. So that's how things are discovered, right? So once we, if we don't know any phenomena, we basically test it out without precautions, and which might lead to some harmful effects, right? So the scientific have also dedicated their lives so just to basically, we are learning these properties at this time, right? So these have been proven experimentally also, right? So don't just cater in कि हाँ sir होता है, okay, okay. It is practical. You can also find these properties in practical scenarios. So always try to relate every concept, since physics is the study of physical world. All the properties which we learned, all the concepts which we learn in the class, they're all found everywhere. Just look around you. Yeah. Let's just look around at your wall, right? You can see the wall. So the light from the bulb is hitting the wall, it's basically reflecting, bouncing back, and it's hitting your eye, right? So we have reflection over there. It's everywhere. Okay, so the first type of wave which we will start learning is the light wave. So if you just recall the EM spectrum, always whenever I start a type of wave, I'm going to take you over there. So you can see that the light wave is basically here, right? It is the visible spectrum here, right? It is the visible spectrum here, which we're starting right now. So this is pretty easy to understand, right? So let's start from here. So for visible light, basically the electromagnetic spectrum, the red light has the longest wavelength. So I'm gonna tell you a mnemonic for this to learn it. So we have Roy J wave, right? We have Roy J wave, a shortcut to learn this. Let me draw it on the other side. I want more space. Let me insert a slide here, a blank slide. Okay, so we have Roy J wave, right? This is the entire white light spectrum. Okay, if we combine all of this color together, it forms white light. Okay. So red basically is R. So R stands for red color. O is for orange. And Y is for yellow. And then G is for green. If you have any questions, please raise your hand and ask again. And B is for blue. And I is for indigo. And V is for violet. Right? So this is the entire visible spectrum over here. So you just need to know the boundary values. Okay? So red has the longest wavelength. It has the longest wavelength. That is 700 nanometer. And the violet has the smallest wavelength, shortest wavelength. A good term to describe this. It has the shortest wavelength, that is 400 nanometer, right? And you can find in between, just finding out. You don't need to learn the middle values over here. If you know the boundaries over here, you can justify the other setup using by just learning this mnemonic here, right? If you have learned this mnemonic, you would be able to sort it out depending upon the highest to lowest wavelength here, right? So that is the way to remember this particular white line spectrum over here. This is what is written over here. K wavelength of red is around 700 nanometer, right? If you convert this into nanometer, millimeter, this much millimeter is 700 nanometer, and violet has the smallest one, that is 400 nanometer, right? So baki jo colors hain, they have the immediate values in between. Okay, you just need to learn this mnemonic here. You'll be able to basically list it out and sort them out depending upon the wavelengths, right? So since speed is equals to lambda f, ठीक है, it basically says that red light has the lowest frequency. We just recall this formula. Just recall this formula. The chapter 1 of waves speed. Okay, ठीक है, perfect. So now this is basically the entire. अच्छा, I was saying कि formula. So if you just recall this formula, which we learned in the first chapter, speed equals to lambda f. Again, if you basically relate the lambda and the frequency, the relation is basically inverse relation, right? Which I had told you multiple times now. So again, if red has the longest wavelength, if I talk about only the visible spectrum, so it would have the shortest frequency, right? For this particular spectrum, right? And similarly, violet would have the highest frequency if you compare it with red, right? This is what is written over there, highest frequency. We also find it out, ठीक है? So let's find it out also. So हमारे पास क्या है, हमें पता है ना रेड की क्या है, तो we know कि speed for all EM wave is fixed, so speed is equal to speed of light, that is 3 exponent 8 meter per second, right? And let's figure it out for red color. So red के लिए हमें wavelength क्या पता है, हमें wavelength is basically 700 nanometer, and nano means basically 10 की power minus 9, right? So you can find the frequency easily. What is the formula? Speed is equals to lambda f. Just make f subject, so it becomes speed upon lambda. Just put in the values. It's 3 exponent 8, speed of light, divided by the frequency, the lambda, that is 700 exponent minus 9. So what is the frequency coming out to be? Should be in hertz. So let me find it out. So it's going to be 3 exponent 8 upon 700 exponent minus 9. So the frequency is coming out to be 4.29 exponent 14. 4.29 exponent 14 hertz, right? That is the frequency that is coming out to be for the red wave, right? Hertz का C बताइएगा. Similarly, you can figure it out for also violet. Okay, now you know the steps. I'm going to skip some steps here. So you know this lambda is basically 400 nanometer. So just put it into the formula. So frequency is going to be 3 exponent 8 divided by 400 exponent minus 9. You can compare the values now using numerical values also. So it should make more sense. 3 exponent 8 upon 400 exponent minus 9. The frequency of violet is coming out to be 7.5 exponent 14. Right? And you can see violet has the greatest frequency here. That is the relation, inverse relation over here, right? So I can write down the value also over here. Here is the frequency की value है, that is 7.5 exponent 14 hertz. And इसकी frequency की value is 4.25, 4.29 exponent 14, right? So that's how, if you know the formula, you can just directly relate the relation, right? So if you want proof, this is the proof here, right? Okay, so if visible light is clear, give me a thumbs up. If visible light of this part of the spectrum is clear, give me a thumbs up. Okay, it's clear to Hamza. Okay, Mashal, that's good. What about Varda and Maeve? Is it clear? Okay, it's clear to Maeve. I'm waiting for Varda. Varda, any questions? Okay, I guess she's having some internet issues. I'm gonna move on. ठीक है, so यहाँ पर ये लोगों ने बोले कि wavelength of lambda is greater, so all colors travel with the same speed. ठीक है, so therefore frequency of word is the greatest over here, right? And then now they're saying an important point over here. You should notice that it is the frequency of light which decides color, right? So deciding factor जो होता है, the scientific method to basically identify if it is yellow or green, they use frequency values. ठीक है? Again, you have intensity. ठीक है? Can anyone tell me कि if you have a flashlight, if you have a flashlight, right? And if you have, let's say, small light coming over here, ठीक है? So if I increase the intensity here, let's say intensity क्या है? It is the amount of light that is hitting a particular area, right? So the amplitude is basically depending upon the intensity here. Amplitude क्या होता है? If you recall the sine wave, this is the amplitude here, right? The distance from the mean position here. It is the amplitude of a wave, right? So amplitude of a wave is directly proportional to the intensity, right? Intensity क्या होती है? How bright a light is, right? So if you have greater amplitude, you have a greater intensity of the light. ठीक है? Just experimental way over here. तो brighter it is, ठीक है? So जितनी हमारे पास amplitude ज़्यादा होगा, तो greater the intensity will be and greater the brightness will be. ठीक है? So amplitude is the factor which decide this particular way over here. The next thing which we have in the pipeline is a question. जल्दी से बताएं. Solve it out. You have a minute to solve it. So you have wavelength of particular wave of light. ठीक है? You want to find its frequency. The formula for this is speed equals to lambda f. And you know the speed of every electromagnetic wave is same as the speed of light. That is 3 exponent 8 meter per second. You have 2 minutes to solve this. जल्दी से let me know once you're done. Raise your hand if you're done. ठीक है? I want the answer from everyone. I want Mashal to give me the answer. Mashal, once you're done, state your answer verbally or in the comment. Okay, ji. Mashal is done. Yes, Mashal. What is the answer? 6 exponent 14. I guess this is pretty close. Okay. So everyone, you can just compare the answers now. I'm starting to solve because we like in the number of minutes that we have right now. So formula आपने लिखा speed equals to lambda f. This gives you 1 mark. Then just put in the values here. So what do you know? You know the wavelength that is given to you. Okay, that is 5 exponent minus 7 meters. Right? You want to find the frequency, just make frequency subject, speed upon lambda, put in the values and get your answer. 3 exponent 8 divided by 5 exponent minus 77. And therefore, your frequency is coming out to be some value which should be in hertz. Let's say the question is of 3 marks. So this will give you 1 mark. The final answer will give you 1 mark. The remaining steps will give you the remaining 1 mark, right? So if your answer is wrong, your steps are fine, you will get 2 out of 3, right? That's how the CAI create your games. So it's 3 exponent 8 divided by 5 exponent minus 7, which gives a value of 6 exponent 14. That matches the Mashal answer, and hopefully everyone's answer is matching over here, right? So if everyone's answers are matching, give me a thumbs up. May you got the same answer. That's good. What about Vardha, Hamza? Okay. Vardha got the same answer. Hamza, are you here or you're just chilling out? Hamza, raise your hand if you're here. Okay. You're not here. ठीक है. That's smart. अच्छा जी. So let's finish 2 more types and then we'll end the class. ठीक है. अच्छा जी. So next 2 types which we have in our end is basically infra and ultra, right? Then we will basically stop here. We'll start from radio in the next class. It is just very simple. ठीक है. It's just what are these waves and where are they used. ठीक है. That is what comes in your exam. The most important part in this chapter is this this thing. You should know the order of the waves. We should know the basically which one has the highest wavelength and which one has the lowest wavelength, which one has the lowest frequency and which one has the highest frequency, right? And the basically properties of these waves, okay, and the basically light waves values. Apart from this, it's just theoretical, right? And you all have seen this practical lives. I believe till now you might have seen all of the waves in your life. Okay, infrared radiation. Can anyone just give me an example कि ये कहाँ पर होती है in real life example? You use this multiple times. You use this daily. You use infrared radiation daily in your life, and it is the most easiest or let's say most commonly found appliance in your house. Can anyone take a guess? Ashal, where do you see this infrared? You can guess. I'm not judging you. Infrared sensors. Yes, but the most common thing which you have in your house is a television, right? You have a television, right, in your homes. And how do you operate the television? Using a remote, right? And how does this, if you might have observed, there's a small bulb at the top, right? So this basically generates a wave which basically operates the television over here. And that wave is basically the infrared wave that I use here. Okay? Voila. You might have check it out. So how can you observe this wave? You can just take your camera, ठीक है, take your camera and just record this, ठीक है, just take your phone and just record this when you basically operate the remote here. There would be a small light which is flashing whenever you basically click any button here, right? That is basically generating IR wave to basically control the television here, right? So our bodies basically are generating IR wave, and we also can basically detect it if we feel hot, right? So if you have also seen we have heaters, right? If you go to Murray or basically Nathia Gully or any northern area, you might have seen heaters which are basically glowing orange, right? So they are basically emitting IR wave, and you basically whenever you go close to a heater, you always feel warm, right? That is the symptom that your body can act as sensors. they can detect IR waves over here, sometimes called radiant heat or heat radiation, right? So anything which is basically hot but not glowing, okay, it emits IR only, right? If anything, let's say if the temperature of this is less than 500 degrees Celsius, obviously you won't have a you won't have a heater which would generate a temperature of 500 degrees Celsius. It would melt your body, okay? So it basically let's say produce 50 degrees Celsius heat, okay? So this is the region where you will find IR waves, okay? So yeah, you can see the elementary of electric fire. This is the example over here, which is the example of which are producing IR waves, okay? But some things which are basically at around 550 degrees Celsius, they emit both. Okay, they emit both. Okay, they emit white hot plus IR waves over here, right? So if anything is at 1500 degrees Celsius, they basically emit visible light plus IR wave. Okay, and where you can basically find this in real life applications, we have thermal imaging cameras. If you imagine, let's say going to a doctor, they might use a thermal camera to basically measure your body. Let's say if you have some abnormality in your skin, they might use thermal imaging sense cameras over here to just to detect kahan pe aapki skin is acting abnormally, which shows the hot spots, right? And you can basically allow the operations to be basically carried out depending upon your uh, basically issue in your body over here. Also, they are used in satellites as sensors. Okay. I also made some project in my university, which I would like to show you. We used IR sensors. Just give me a second. I can find a video. Let me show you my creation. Okay. The magical creation. Okay. My Zoom is acting weird. Let me just go towards my edge screen. I would want you to guys for wait for 30 seconds. And I also basically do some editing on my own. I also want to show off my editing skills. अच्छा जी, YouTube share. Thank God Chloe. So we basically made an RC car. What is an RC car? It is a remote control car. उसके अंदर हमने sensors लगाए थे to basically detect enemies. ठीक है? So let's say if we have, you might have watched Metal Mania, right? Where you have robots crashing robots. So it's sort of that creation, right? Let me take you over there. Here is my videos. Uh, your videos, video channel. Okay, so let me share the screen and let me share the sound. Actually, so this is my account. If you want to stock, can ठीक है जी, and let me share the sound stereo high quality. This is the project which we made. ठीक है, so yeah, let me take it to 480p. अच्छा, यहाँ पे if you see this, this is an IR sensor. ठीक है, इसमें एक रिसीवर है, एक emitter है. Similarly, here we have IR sensors here. ठीक है. So what was happening? We have basically coded this entire mechanism. So if anything was closer to this, less than 30 centimeters, so it would basically bounce back, right? So this is generating IR waves here. So sort of, it was a sort of fighting mechanism. Okay, so we had fighting tools, we had defending tools, we had basically dodging mechanism. This is the IR sensor over here. So if anything is closer, it goes back and flips. Okay. अच्छा, यहाँ पे वी हैव डिफरेंट टाइप ऑफ सेंसर्स हियर, दिस वाज अल्ट्रासोनिक सेंसर, ठीक है। सो ये साउंड वेव्स पे चलते हैं हमारे पास, विच इफ आई गेट टाइम आई एक्सप्लेन कैसे चलते हैं। Right, so this is just an application in real life which you can find over here. So they will also sense sensors, okay, so say they sense environment by sending and receiving infrared waves over here, right? I believe that was interesting, okay. Again, what are the other uses which you can where you can find IR waves? Again, remote control of televisions, okay, or any player, okay. So it is using basically IR waves. Why are they used for these applications? Because they can work for short range communication, right? लेट्स से टीवी को हमने ऑपरेट करना है शॉर्ट रेंज, राइट? इफ आई वांट टू, लेट्स से इफ यू सॉ द वीडियो, उस पर जो हमारे पास बेसिकली सेंसिंग हो रही थी, इट वाज ओनली फॉर 40 सेंटीमीटर, राइट? तो इट वाज प्रीटी शॉर्ट रेंज एंड इट कैन बी यूज फॉर लॉन्ग रेंज, ठीक है, यूजिंग ऑप्टिकल फाइबर, ठीक है, बिकॉज इट कैन ऑपरेट basically high rate of data transmission, which can basically lead to good communication rate. Then the last thing which you want to cover is ultraviolet radiation. And where can you find ultraviolet radiation in the spectrum? It is above visible light, right? After visible light on the right. Okay, so after visible light, you have ultraviolet. Okay, so we have covered what? We have covered right now, we have covered what? Let me just mark it out. Okay, my PowerPoint is going to die. Hopefully not today, but soon. I have 2 minutes of it here. Achha. So we have visible light, we have covered visible light, we have covered infrared waves. Now basically starting ultraviolet rays over here. You can see, just remember the order over here. So after, on the right of visible light, if you follow this particular order, we have ultraviolet, right? And if you just see this, ultraviolet will have basically greater frequency as compared to visible light. You can see that, right? Highest point is here, but it would have smaller wavelength frequencies as compared to visible light, right? Okay, so that is the point which you should always refer towards. ठीक है, so what is UV light? Can anyone share कि UV light की source क्या है हमारे पास? What thing is producing UV light? It is found around the
Sir, the
world.
sun.
Yeah, it's the sun, right? It's the sun. So ultraviolet have shorter wavelength than light, which you can learn from the basically the diagram which I draw. ठीक है, they cause suntan and produce vitamins, right? So what is the golden rule? What is the golden rule for producing vitamins from your, by using sunlight? You should only take a sunlight for half an hour, right? Which I follow. Just take sunlight for 30 minutes. It is pretty good, which basically vitamin D, and it basically produces other vital vitamins for your body. If you exceed this limit, again, it is harmful, right? Everything in excess is harmful, right? So, but too high an exposure can cause basically skin burns, stickers, so on and so forth. They can also cause fluorescent paints and clothes washed in some detergents to fluoresce. You might have observed that you bought a black t-shirt, right? You bought a black t-shirt. Let me draw it out. Okay, good. Zabardast. You bought a black t-shirt, right? But after some days, when you are basically wearing it daily, the black always basically fades to, let's say, grayish black, right? And why is that? Again, a drawback of UV. Okay, it basically fluoresces basically diminish the color. It basically what happens is basically absorb UV light and basically disrupts the color particles of the of the shirt, and it basically lead towards fluorescing of the color over here, right? And they glow by re-radiating as light, okay, because there's obvious UV over here, okay. So if the UV light is incident on your t-shirt, it basically causes the particles to again start to re-radiate, because already light is hitting on them, but we have again UV light extra, which is harmful if we are exposed for a long amount of time. That basically can lead to decolorization of your color over here, right? This effect may be used in security marking to verify invisible signatures, ठीक है, on bank documents and to detect fake banknotes, ठीक है. If you have watched some basically detective movies, might have observed that to catch the fake notes, they use UV light, right? Because if you have used the fake ink, it would basically causes it to decolorize, and you can just note के note fake है या real है, ठीक है. So again, useful effect also and harmful effects also, right? I'm going to just introduce about radio waves, and then we're going to start from here. It's just the type of radio waves, and then we have another type of radio wave. Microwave is the most easiest one. ठीक है, you find this daily in your house. ठीक है, X-ray आप जा चुकी हैं. You might have seen this in hospitals. ठीक है, and then gamma. then dangerous about this. Just it will just take 10 more minutes in the next class. So radio waves, what are radio waves? Can anyone give me a summary or a comment in the chat? Whatever you know. Radio waves, just a one sentence, one line sentence. What are radio waves? I want good participation in the class. Anyone? Give me a guess. So I want you guys to participate so that I can know your loopholes. We're getting stuck. Hamza, बताएं आप. What are radio waves? Quickly. Everyone wants to end the class and they want to go to homes and they want to have their dinners, take care, watch some movies. I know, I'm taking some extra time here. Acha, just tell me कि where do you find this in real life? Radio waves. Hmm. Anyone? Where do you find radio waves in your real life applications? You have observed this.
Sir, maybe for
It's
when
9/11.
sir, can I say?
Yeah, sure.
Sir, maybe for example, when we send like a submarine underwater and we need to like check the surroundings, I guess we use radio waves.
Perfect. ठीक है. And I have a comment from Mashal. Mashal को याद है the pattern. That's good. It has the longest wavelength. It has the lowest frequency used for communication technologies. Perfect, right? Whenever you start a new type of EM wave, go towards the first, second page. Okay. ठीक है. This is the summary here. ठीक है. So radio waves is basically at the start point here. It has the highest wavelength and the lowest frequency. Right. Higher wavelength means it can travel for a longer distance. Right. Higher wavelength means longer distance travel. Higher frequency means it has high energy. Okay. So this means it has high energy, right? And this means it can travel furthest, can travel the furthest, right? Acha ji. So now this is just the type of wave which has the greatest wavelength and smallest frequency, therefore can travel greatest distance, and therefore it is used in communication, right? It has a longer wavelength in the electromagnetic spectrum over here. Again, they are used. Aerials क्या होते हैं? They are basically, if you just recall this, we have a satellite, right? Sort of a satellite, and then we have a satellite in space. Okay, and this is the boundary of your Earth. Oh my God, it's a very good Earth. Okay, this is the boundary of Earth. So basically, they are used for communication, right? So they send waves here, transmit it back over here. Okay, so they can travel furthest, and they basically can carry sound data, pictures data, and other information, right? Let's say if you make a call, let's say Mashal and Hamza are talking over call. Okay, let's say they are talking over a call, and let's say Mashal is in Lahore and Hamza is in Karachi, right? Okay, so what happens? This phone sends a signal, okay, using radio waves. This goes to a satellite, right? It is boosted and it basically comes back to Hamza over here, right? So again, it has the longest wavelength, therefore it is used in communication over here. So we have the first type of radio wave that is called long, medium, and short wave, right? So the wavelength of this type of radio wave is, this is again, we're talking about radio waves here. We're talking about radio waves. And the lambda range for this is basically from 10 meter to 2000 meter, right? So if any wave that is the radio wave that is lying between, that is a wavelength in between this range, they would lie in the long, medium, and short wave, right? So again, what are the properties of this sort of waves is as follows. Okay, if you see this diagram here, so if you imagine that there is a station, okay, there is a station here which is broadcasting, let's say some media, okay, or let's say a television show, a live television show. So if you are using this particular range of radio waves, they might get diffracted also, right? Let's say they cross a sharp ending, they also get diffracted here. You can see that, right? So that's how they're also able to reach our homes, right? So this mountain is sort of a design parameter here which they have used, because as soon as the wave cross and basically hit this boundary here, they also start to diffract here. We have learned diffraction, right? What is diffraction? When the wave pass through sharp endings, it bends, right? So this bending is beneficial here because since it is allowing the waves to basically reach to the house, right? ठीक है. And these sort of waves do not, if we assume, if we recall, our Earth, ठीक है, our Earth has ionosphere, right? We have atmosphere, and then at the boundary of the Earth, we have ionosphere, right? Which blocks out the harmful radiation of the sun. Let me draw it perfectly, right? So this part is called the ionosphere. So which basically reflects the radiation from the space too. Okay. So and also basically reduces the amount of sunlight, the intensity of sunlight, so that it does not cause harmful effects on our skins. Right. This is called ionosphere. So these sort of waves are basically can also be designed to be reflected from ionosphere. Right. You can see that the wave hits this, okay, this ionosphere, and it basically gets reflected and goes to a receiver here, right? So this is also one of the example of communication design which is used in industry right now. If we are using the radio waves, which lies between long, short, and medium radio wave range, they can be used in two methods of communication, right? Either using diffraction or reflection over here, right? Okay, so they diffract around obstacles, so can be received even when the hills are in their way. They are also reflected by layers of electrically charged particles in the upper atmosphere, that is ionosphere, which makes long distance radio reception possible here, right? Let's say you might have heard about some game in which we have a sort of a remote, which is sort of this. Okay, we have a remote like this. Okay, it has an antenna over here. Okay, and some basically military people uses this to communicate, right? So they also basically produce waves which are from this category over here, right? ठीक है, and then let's say if another person is here, so the wave gets reflected from the ionosphere and it is reflected back to basically the receiver here, right? So that's how they can communicate here, right? This is the first type of radio waves. It's, I guess it's pretty simple here. If it is clear, give me a thumbs up. ठीक है. It's clear to Varda. That's good. It's clear to Hamza. It's clear to Mashal. That's good. It's clear to everyone. That's good, right? If you have questions, please just pause me in between. You can raise your hand. ठीक है. This is just, again, as I said, the most important part in this syllabus, in this chapter, is basically learning the trend of the waves, the EM spectrum, and the boundary values, okay, and the visible light spectrum, red color wavelength value, and the violet color wavelength value. The other thing are just applications, where are they used, okay, and list some drawbacks and help basically good effects of these waves in practical life, right? Otherwise, you're good to go. ठीक है जी. So let's continue the last type of radio wave. Okay, this is again, we're continuing radio waves here. Just to be specific, I'm writing down the heading here, right? It is still we are doing radio waves here. The first, these two types are basically interesting. So we have very high frequency here, and then we have ultra high frequency waves here, right? And this is basically lies in the range of wavelength from 10 centimeter, that is 0.01, 1, 2, 3, 0.001, 0.001 meters to 10 meters, right? एंड इफ यू रिकॉल दिस, यहाँ पे हमारे पास वेवलेंथ ज्यादा थी, राइट? यहाँ पे हमारे पास वेवलेंथ कम हो रही है, बट स्टिल दे आर लाइंग इन this particular spectrum here, right? And if you recall the formula, that was P is equals to lambda F. If you relate lambda and frequency, the formula becomes speed upon frequency. And the relation which is coming out from the lambda and frequency is inversely linked over here, right? Why is it named very high frequency and ultra high frequency? Because you have decreased the wavelength now, right? So if you have decreased the wavelength, you are operating at high frequencies, right? Okay, I hope it makes sense. So the shorter the waves, these shorter wavelength radio waves need a clear straight line path to the receiver. They're not reflected by the ionosphere over, right? They're used for local radio and for television transmission over here, right? So astronomers use radio telescopes to pick up radio signals from stars, galaxies to gain information about universe which cannot be obtained from optical telescopes here, right? So again, what is the property of this wave? Let's say we have a transmitter here and we have a house here, right? Right? We have a transmitter here. Since it is operating at high frequency, it is going to go at a very fast rate, right? ठीक है जी. So let's say we are sending this wave. ठीक है. And this wave cannot be reflected, which is very important over here. Cannot be reflected by ionosphere, right? So let's say if you hit ionosphere, it's going to go out into space, right? Let's say this is Earth over here, and then we have ionosphere here. And if the wave basically crosses this, it's going to go into space, right? Cannot be reflected over here. So that's why we need to basically send these sort of waves in only straight line direction, right? In a straight, clear path. There should not be any mountains in between and not any blockage in between, right? Over here. Okay. So, and where do you use this? In local radio and for television transmission over here, right? So sometimes astronomers also use to basically observe okay, how is the data, how is the star looking like. Let's say we have, let's say this is Earth here, right? And there is a satellite here. It is rotating around certain orbit. This is Mother Earth, and let's say they are watching right now planet Mars. Okay, they are observing Mars here, right? Mars is also orbiting around a certain orbit around Sun, right? And this is Earth orbiting around certain orbit around Sun, right? Let's say this is Sun here, right? So now sometimes satellites basically can also use this to have straight line communication. Let's say they have a camera here, they have a rover here, right? Mars rover, let's say they have a camera rover here, that is Mars rover, which is a rover which is moving around Mars, right? And he has captured some pictures on Mars. Now he needs to send it to a satellite, right? And then satellite basically send back to the Earth here, right? So what happens? How does this communication works? It basically sends data in straight line without blockage, and then this data is basically sent back to the Earth, to NASA or SpaceX to basically have some observations here, right? So this is again it can be used in space. Why? Because it will not be reflected by ionosphere, right? Because ionosphere is the basically region at the boundary of planet, which basically helps to block out the harmful radiation, right? Since it cannot be blocked by any ionosphere, so we can use it to basically have communication from planet to planet, right? It can easily go from satellite to Earth. It would not be reflected back over here, right? So that is again a radio wave, a type of radio wave which is used in communication which involves television, ठीक है, astronomy, ठीक है, and local radios, right? FM, let's say we have FM 91, we have FM 106.2, 107, and so on and so forth. Okay, if it makes sense, give me a thumbs up. I'm going to start another type of wave which is called the microwave wave. It makes sense to Verda, Maeve. That's good. That's good. Makes sense to Mashal also. Hamza, clear है? Okay, good. ठीक है जी. So now I'm gonna start microwaves and let's again go back to the second slide. ठीक है जी. So what have we done till now? We have completed visible light. We have completed then infrared wave. ठीक है. And then we complete ultraviolet waves over here, right? And then we went towards radio waves. We have learned the type of radio waves that involves long, short, medium waves, and then ultra high frequency waves and very high frequency. Right. Then now we're gonna start basically microwaves here, right? So this is how we are learning over here. As you can see, it is very close to meridian waves. It would have wavelength which is greater than infrared, visible light, ultraviolet, X-ray, gamma, but it would be lesser than the radio waves over here, right? Okay, dear. And let's start this. Okay. So again, that's you just need to know rough estimates, right? So microwave has wavelength of a few centimeter, right? So it can be basically again in centimeters here. Okay. So why where are they used? They are used for international telecommunication. Okay. Direct broadcast, satellite television. Okay. We are geostationary satellites. Again, mobile phones, networks, yeah, microwave, aerial towers over here, and it is used in wireless applications here, Bluetooth device, ठीक है, short range communication, ठीक है. uh, let's say if you use Bluetooth to transfer mobile videos, pictures, ठीक है, games, so on and so forth. They also use for cooking, right, which is pretty common in every household. Okay. So what do they do? They cause the water molecules to resonate. Okay. And since they vibrate, they basically hit a certain frequency of the microwave. And since we know that the energy is proportional to frequency, so if the water molecules are vibrating at a frequency of microwaves, they have gained more energy. And since energy is measured in joules, it basically heats up your food, right? Okay, so that rhymed, right? That rhymed. That's good. Okay. So again, you just need to have a rough estimate of its wavelength. That is, it has a wavelength in just few centimeters, and just learned at least two applications of each type of wave, right? So यहाँ पे it is used most commonly in cooking, right? Because we have seen microwaves are in every sort of place, from restaurant to hospitals to offices to households to, let's say, hotels, okay, so on and so forth. There are microwaves everywhere because it is very easy to basically just heat up your food by just rotating a knob, right? And again, how do they heat up the food? They basically vibrate the molecules of the food at the frequency at which they are operating. Okay. And since energy is proportional to frequency, so if you increase the frequency of a particle, it gains energy, right? Since energy is produces thermal energy, okay, it's in joules, so it heats up your food, right? And it is used for short range communication, right? Let's say Bluetooth. So Bluetooth is basically operated by microwaves. And if you have geostationary satellites, right? So they are operating at microwaves over here, right? So I guess this makes sense. It's pretty simple, right? Just a brief summary about microwaves. That is what is required for your syllabus. If it is clear, give me a thumbs up. Okay, if it is clear, give me a thumbs up. This part of microwaves. Okay, it's clear to Hamza. Good. It's clear to me. That's good. It's not difficult. Just introduction about microwaves. You should know okay, where it is placed in the EM spectrum, and just learn two applications of it. Right? That should do the maths. Okay. The most interesting and most famous one is the X-rays. Okay, among my O-level kiddos. So it is the most easy one to understand too. First of all, whenever we start, again go back to the third slide here, because that basically dictates okay, what have we done till yet. So we have learned the microwaves now. Okay, so we are starting now the X-rays over here. Since you can see it's pretty close to gamma rays, it would have very small wavelengths but greater frequencies, right? Okay, Ri? So let's go over there quickly. Okay, so again, there are some methods to produce X-rays also, okay, which we will learn in chapter number again in radioactivity. You will learn okay, how is it produced over here, okay. And X-rays are produced basically when high-speed electrons are stopped by metal target. Okay, an X-ray tube over here, right? So they have smaller wavelength than ultraviolet. You know that, right? So we have what? We have microwave. We have sorry, radio wave first. We have microwave. We have infrared wave. Okay. We have visible light, and then we have ultraviolet, okay, and then we have what? X-rays, right? So you can see okay, the wavelength decreases from here, right? So wavelength decreases. So it's on the right hand side, so it has smaller wavelengths as compared to ultraviolet, right? So how is it used? X-rays basically are mostly done in hospitals. And why is it useful in hospitals? Because X-rays can pass through muscles, right? Let's say if you have muscles, this is the boundary of muscle here, and this is the boundary of bone. right? This is the boundary of a bone, right? So what happens if you basically pass X-rays? It can easily pass through the muscles. This is the muscle here, and this is the bone, right? And can basically come back over here, right? So it basically goes through reflection from bone, and this is the camera over here, which is fixed on the device, which is getting used to have X-ray, which is in the X-ray machine. Okay, so it basically maps out the image of your bone, and it can help to find cracks in bones, right? Where do you have fracture, so on and so forth, right? So they can penetrate through solid objects and affect a photographic film with materials such as bones, teeth, metals, which do not pass through easily. So you can take shadow pictures, okay, and that can help you to basically solve out the results, and that is basically giving you the answer over here, right? And if you can see the picture here, so what you can see here and is that okay, you have an alarm clock and then you have a bone here, right? So what is happening here, if you basically can see, it's in hand of a person here, right? And the clock has different parts. It has plastics, it has basically some other materials and also metal, right? So metal can reflect the light. Okay, so what happens if you does x-rays here, the x-ray basically goes through your muscles easily. This is your sending of x-ray here, right? And this basically reflects back over. Okay, similarly if it hits the metal, it reflects back, right? So this is reflection which is taking place here, and it goes to your camera that is fixed in your machine of X-ray, which basically captures the details here, right? So again, you don't need to learn any formulas about this. You just should just know, okay, where does it lie in the EM spectrum, and how is X-rays basically getting carried out here, right? Okay, so this is how X-rays works, right? So if it is clear, give me a thumbs up. Okay, it's clear to me. It's clear to Hamza. Okay. Okay, it's clear to Varda also. That's good. Okay, ji, that's good. So now again we are approaching towards the last part of the spectrum, that is the gamma ray, right? Can anyone explain what is a gamma ray? Just by seeing the spectrum here. हाँ जी, कोई बताएगा? What is the property of gamma ray which you can see? Yes, gamma rays. Anyone? Okay, so again, what you can observe from the spectrum is that it is on the rightmost part of the spectrum, right? It would have the lowest wavelength and the highest frequency, right? Since it has the highest frequency, it would have the highest energy, right? And if it has the highest energy, it is the most penetrating over here, right? Okay, so let's continue. TKD. So gamma rays, right? So again, harmful, right? X-rays are harmful. You can have X-rays only after a span of 6 months. Let's say you have an X-ray at a particular time, you should have another X-ray after 6 months, because the particle which is absorbed by your body, okay, can take time to basically get removed from your body after some certain time, right? So you learn these formulas in A levels, inshallah. There are some formulas which links the time also, right? So Hanji, so again, the most harmful one is the gamma ray, right? You should be, you might have observed, let's say if you go towards an laboratory, we have basically a power plant, which is CANUP, okay? It is CANUP, okay? It's a single P. So it's a Karachi nuclear power plant, right? It's double P, by the way. So who has seen or basically went across CANUP power plant? Has anyone seen this? If yes, raise your hand. Can a power plant anyone? So it's basically a nuclear power plant, right? It uses uranium over here. So uranium basically produces gamma rays. Okay. So over here you always have symbols, right? Have symbols on the boards, which basically makes a sort of a that skeleton symbol here. Okay. Skeleton symbol, which leads to okay, it's dangerous, right? So why is it written over here? Because they are operating in gamma rays, right? So gamma ray is producing over here. And why is it very harmful? Because it is the most penetrating and the dangerous one than X-rays. Okay. Because it has the highest frequency, it can travel at very, it can basically penetrate through any muscle, right? Through any bone also. Okay. Because it has very enough energy to penetrate through any material, right? But there are methods to stop it also, right? There are methods to stop gamma rays also. So they are used to diagnose cancer cells. Okay. So what happens basically, there is a machine in Pakistan also in basically Jinnah Hospital. If you watch a video, this is also for awareness. So there is a machine which can kill cancer cells. Okay. So it is free of cost, and there are operations which are getting carried out over here. So it can even treat cancer in very sensitive areas like brain. Okay. Like basically the part which are very sensitive like heart. Okay. Like lungs. Okay. So on and so forth. And there is also video on YouTube. You can also search on it. It's sort of a machine जिसको मुझे नाम याद नहीं आ रहा. But there is a machine which is treating cancer cells over here. It's pretty advanced, right? And it's all automatic, right? It's based upon AI. Achha, so you're talking about gamma rays here, right? Gamma rays are the most harmful ones since they can penetrate the most. Okay. And again, they are very helpful. That very small amount of gamma ray can kill cancer cell, right? But if you expose yourself to a very little amount of gamma ray, that can basically lead towards uh, again creating a cancer cell, right? So it is used to kill cancer cell, but a little overexposure can also create cancer cells in your body by using gamma rays, right? It's pretty harmful. So there it is used pretty it is used by basically operating using computers which are automated, right? They are basically controlled by AI. So it's pretty precise, and a normal person cannot basically just take a machine in his hand basically, and just basically expose the patient using his manual control, right? That is not, we are not so much accurate, right? We have human error that is around 0.05 seconds. That's way too much, right? So how can it kill cancer cell? It can also kill harmful bacteria in food and on surgical instrument, right? So how is it basically getting used? So in radioactive tracer, which is basically a machine which emits gamma rays, okay, and is basically absorbed by the cancer cells in a patient body, right? So how is it basically operating? We have a machine which is basically have a gamma source. If you basically press a button by a machine, obviously when it is operating it exposes the patient with a small amount of gamma ray, and that gamma ray is basically absorbed by cancer cells, right? Which basically can kill it, right? Uh, and it can also basically kill tumor. Okay, that is again a cancer disease over here. And in engineering, it used to basically detect cracks. Okay, so in buildings, वगैरह. So it's used everywhere. But again, with precautions. Marie Curie, a scientist, died basically using a gamma rays by basically keeping a uranium material, a uranium stone in her pocket, right? So now again, we have seen all the topics, basically all the type of waves, their benefits, and their applications, right? Now it's time for their drawbacks, right? So if it is clear till now, give me a thumbs up. If it is clear till now, give me a thumbs up. It's clear to PF. That's good. It's clear to Varda, Mashad, and Hamza is left. Hamza भाई किधर हैं आप? इधर ही हैं या फिर आप उधर हैं? अच्छा इधर ही हैं. ठीक है. That's good, right? So now, gonna basically just briefly go through, sorry, the dangers of basically these electromagnetic radiation. Right? Again, everything is useful, but in a certain quantity. If you basically overexpose or overuse a certain radiation, it is again harmful, right? Okay, so microwave, how is it harmful? Okay, so if you are overexposed to microwave, what can you do? It can do the following thing, right? It can produce heating of soft tissue in the body, right? And this can damage or kill the cells. So there is some debate at present as to whether they are used in mobile phones is harmful. Okay. Hands-free mode where separate earphones are used may be safer, right? So again, microwaves are used in your phone, right? So when you make a call, so a microwave is basically emitted from your phone. When you receive a call, a microwave is basically hitting your phone, right? And then when you talk over a phone call, right? So it's again, you might have heard some cases where the person who basically was talking over a call for a long period of time lead to some basic damage of his ear, right? So what happens? So basically, when in microwave are hitting your ear or any part of your body, so that can basically damage. It can basically uh, damage your cells, right? By hitting it, right? Because whenever you go talking over a call without using headphones or let's say earphones, so you're directly exposed with basically you're directly in contact with the mobile phone, right? With the with your ear or with the part of your brain. So that is basically constantly getting hit by a microwave. Okay, and obviously your phone got heated up, right? So it can do what? It can heat up your cells, the soft tissue in your brain or soft tissue near your ears, right? Which can basically again destroy cells. And if the cells are destroyed, again that can lead to cancer, right? So that's again a drawback of it. So the solution for this is basically get, getting introduced to headphones, uh, wireless, basically sort of devices which can basically be able to talk to you. Like it could have earphones, earplugs, or let's say dongles, which can basically are separated from the mobile phones. So that is again one of the solution which we are thinking about. Again, we have problems, and engineers are there to basically solve your problems over here, right? So, but at least we should know, okay, this is an issue which can cause it, right? So that you can avoid it, right? So always when you're sleeping, so do not keep your phones near your head, right? And always basically go towards mute your phones, because when your phone vibrates, okay, the back of your phone produces the greatest microwaves, right? So if you have a phone and the back side of your phone, okay, where you have camera, so that is the part where you have the receiver and the transmitter, okay, of which basically produces microwaves and receives microwaves. So when you are getting a call, it's basically producing the maximum amount of waves, okay. And when your phone is near your head, let's say when you're sleeping, or let's say accidentally you are over your phone when you're sleeping, and your phone is continuously ringing with which is producing microwaves, that can again lead to this particular scenario that leads towards damaging of the cells, right? These are practical scenarios. We can also watch videos. There are people, patients over there who have basically been diagnosed of this issue, right? Okay. Then we have next, which is infrared waves. Okay, right? Infrared waves कहाँ पे थी? If you recall, if you have heaters in your homes, okay, and if you're using mobile phone, sorry, television controls, remote controllers, yeah, and sensors, so they are basically using infrared communication over here. That is used for small range communication, right? So again, if we have high exposure of infrared, high intensity of infrared, again, that can basically lead to skin burns, right? Because let's imagine if you have a heater, if you have a heater here, right? Let's say you have a heater, and if you do this, right? You touch the heater rod with the bare hand, right? Let's say we have Hamza here. Hamza wants to test physics. Okay, he wants to test physics concepts. So Hamza goes to the heater and he basically grabs it. Okay. So what would happen? Obviously, he would basically burn his skin, right? So that is the drawback over here. Okay. Then we have ultraviolet over here. Ultraviolet is basically what? It is the energy coming from the sun, right? And basically, we have the earth here, right? Which has ionosphere also here, right? We have ionosphere here. So होता क्या है जब light आ रही होती है, it also contains some UV light, ठीक है? It basically reflects back some harmful UV light components, harmful UV light components, right? Which can directly burn your skin, right? So the the filtered UV light, which is basically passing through the filter over here, which comes to the earth, is the one which you're talking about over here, right? Still, it is harmful, right? So it can cause ionization of the skin, right? And which can basically cause skin cancer, okay, including damage. If you look at the sun directly, okay, for more than let's say a minute, it can basically damage your eyes directly. And dark skin is able to basically absorb more because black color absorbs all the colors, right? I'm not big racist over here, so don't basically make this a joke. I'm just saying, okay, if you talk about the colors which we have learned in, right? So white color basically reflects all the color. Right? Let's say if we hit a white surface with the sunlight, it will basically be cold, right? So houses boundaries are painted with white color so that it basically stays cold, right? Because if sunlight hits a, let's say, wall which is white, it will basically bounce back, right? But if you're wearing a black shirt, you basically start to feel warm, right? Because black absorbs all of the light colors, okay? And it also does not allow your energy to escape also, okay? So that is the reason which I'm saying over here, right? So it can basically in the surface layer the skin light color, so reducing the amount of reaching deeper tissues over here. So exposure to the harmful UV rays present in sunlight over here can be reduced by wearing protective clothing such as hat or by using sunscreen lotion over here, right? Again, if you're sun tanning under sun, okay, so you can use basically sunscreens to basically protect the ultraviolet crossing your skins over here. And what does it do? It basically the overexposure of UV light can again create abnormality in your cells, and if a cell acts abnormally, that is basically cancer, right? And how can you protect yourself? Precaution can just wear a hat, basically wear cover your body, or basically if you're taking sun bath, so you can basically use sunscreen, right? Okay, so the last one, which is in the pocket, it basically in the bucket list is basically X-rays and gamma rays, and you all know basically what are the drawbacks of X-rays and gamma rays right now. So, what is ionization? Basically, it causes the atoms to become charged, like anions. If you're taking chemistry class, so it basically these both rays lead towards ionization of the atoms in cells, which can call mutation. Okay, so what is mutation? Mutation is basically if you have one cell, it basically start to produce more cells. Okay, let me just draw it out. So it lead towards extra creation of blood cells, right? And this leads towards extra blood cells. So even if you have extra blood cells in your body, that is again a normal, right? That can lead towards also cancer over here, right? So this is the disease which can basically be getting if you are exposed to X-ray gamma ray over here. So they can be protected by using a lead. Okay, so if you recall, lead is a metal over here, right? Pb, lead is a metal. Okay, lead is a metal here. So you can use the lead, basically metal, to basically absorb this. If you have gamma ray coming from here, it would be basically absorbed by this particular type metal skin over here. And that ends your chapter, right?